Hello friends, welcome to Learner's Planet. Friends, this is our 7th session for the topic electricity. In the previous session, we discussed about the heating effect of electric current. We discussed the working of an electric iron. We discussed the working of an electric bulb. We discussed that how an electric iron works on the heating effect of current. Right? When current is passed, his heating element that is made up of nichrome wire that becomes very red hot and produces heat, and this heat is utilized in ironing the cloth. Then we discussed about the working of the bulb, why tungsten filament is used in producing light through bulb. We know that tungsten have very high resistance and a very high melting point. So since it has very high resistance, it produces enormous heat, and since it is having very high melting point, so it doesn't melt at all, being in a very enormous heat atmosphere. Okay, so it works for a long time in a bulb. In this session, we are going to discuss about fuse. Okay, what is fuse, how it is made, and why it is useful. Okay, so let's begin this session. So the heating effect of electric current is utilized in electric fuse for protecting household wiring and electrical appliances. Now how it happens? Here we can see an electric fuse. This is fuse holder, this is grip, and this is fuse wire. Friends, a fuse is a short length of a tin plated copper wire, and it has very low melting point. And the fuse wire has high electrical resistance than the rest of the electric wiring in our house. Now sometimes what happens, because of any reason, when the current in a household electric circuit rises too much, then the fuse wire gets heated too much because it has very high resistance. Now since it has high resistance, it gets heated too much, it melts and the circuit is broken, right? And if the circuit is broken, then the current stops flowing. Okay, so because of that, this fire or other destructions can be avoided in a house, or we can say we can even prevent the damages to other electrical appliances in the house due to this excessive current flowing through them. Okay, so electric fuse is very important application of heating effect of electric current. Now friends, let's discuss the working of a fuse in detail. The most important part of this fuse is the fuse wire. In normal working condition of electrical network, the electric current that is flowing through this network is within the pre-decided, or we can say rated limit. Now because of any fault in the network, maybe any fault, what happens? The current crosses the pre-decided or the rated limit. Now this high electric current may have very high thermal effect, which will cause a permanent damage to the valuable equipments which are connected in the electrical network, right? So this flow of this high electric current has to be interrupted, right? Which is as far as possible, it has to be interrupted. Here comes the role of the electrical fuse. Now electrical fuse is what? It has a thin fuse wire that has a high resistance, right? It has a resistance that is higher than the rest of the electrical wiring in the house. Now when the current in a household circuit rises too much because of any reason, then this fuse wire gets heated too much, right? And since it gets heated too much, it breaks the circuit. It melts away and it breaks the circuit. And if the circuit is broken, the current stops flowing. Okay, so this way we can prevent the other appliances from getting damaged. Okay, or maybe fire in the house can also be avoided in some cases. Okay, so we have discussed the working of an electric fuse. We have discussed the heating effect of electric current, how it is useful to operate the various electrical appliances. Now friends, it's time to take the numericals on the topic electricity. So we have discussed almost all the concepts and formulae related to electricity. We discussed Ohm's law, we discussed the terminologies related to electricity, that is conductors, insulators, and various other terminologies, right? So let's start taking numericals now. Now friends, let's take the numericals now. A conductor carries a current of 0.2 ampere. I is given to us as 0.2 ampere. Find the amount of charge Q we have to find out through the cross section of the conductor in 30 seconds. Now T is 30 seconds. Now we know the relationship among these three. Q is equal to IT, right? And we measure Q in coulomb. Electric charge is measured in coulomb. So what is I over here? So Q is equal to 0.2 into time is what? 30 seconds. So it will be 30 into 0.2, that is 6 coulomb. Okay. So the amount of electric charge that will flow through this conductor is what? 6 coulomb. I just write it over here. You have to write like this in your exam to get the full marks. The amount of electric charge that will pass through this conductor is 6 coulomb. Okay. The next thing is how many electrons will flow in this time interval if the charge on one electron is this. Now friends, it's very simple. What is the total charge? That is 6 coulomb. And what is the number of electrons? I just write it over here. Number of electrons. See, total charge is 6 and per electron the charge is 1.6 into 10 raised to power minus 19. So if we divide 6 by 1.6 into 10 raised to power 19, we'll be getting the number of electrons, right? It's but obvious. The total charge divided by the charge by individual by a single electron. So it's 6 upon 1.6 into 10 raised to power minus 9. It's 19. Okay. Or we can say 6 divided by 1.6 will be 3.75 into 10 raised to power 19 electrons, right? So number of electrons is this Q, I just write it over here, over charge on per electron. So it's N is equal to Q by E. Okay. Total charge by charge on one electron will give us the number of total electrons. Okay. I hope you are clear. Let's take this question now. The filament of an electric lamp draws a current of 0.4 ampere. I is 0.4 ampere. Time is which lights for 3 hours. That means time is 3 hours. We need to convert that to seconds. So into 60 into 60. Calculate the amount of charge that flows through the circuit. So further the same formula. Q is equal to IT. I is 0.4 and time is 3 into 60 into 60. Okay, just solve it. It is 6, 4 3s are 12, 12 6 are 72, 72 into 6, 60. So it's 4320 coulomb. Okay, so the amount of charge that will flow through this circuit will be 4320 coulomb. Okay. Similarly, over here, an electric current draws a current of 0.5 ampere when voltage is 200 volt. Calculate the amount of charge flowing through it in 1 hour. Same. Q is equal to I, that's 0.5, and time is 1 hour, that's 60 into 60, right? So 5 6 are 30, 36 are 180, and this 0. So it's 1800 coulomb, nothing else. Very simple. Now friends, let's see this question. N electrons flow through a cross section of a conductor in time t. If the charge on an electron is E, write an expression for the current in the conductor. I assume the current is I, the charge is Q, the time is T. Okay, now what? Q is equal to IT. Now friends, here Q is the total charge, right? Now charge on one electron is E, right? Charge on, I just write it over here. charge on one electron is E. That means the total charge on n electron will be what? Ne, right? And this total charge is nothing but this Q, right? So I just put the value of Q over here. So that's Ne is equal to I into T. Now I have to find out the expression for the current in the conductor. So I will be what? Ne by T. Okay, it's very simple. Q, the total charge, is equal to current into time. Charge on one electron is E. Charge on an electron will be Ne, right? So the total charge is Ne that I put over here. So Ne is equal to IT. That means I is equal to Ne by T. Okay, that is the expression for the current in the conductor. Okay. Now friends, here we have to find out the current. Here charge is given to us. Q is equal to 0.5 coulomb and time is also given, that's 5 seconds. And we know that Q is equal to IT. I is what? The current. So Q is 0.5 is equal to I into T is 5 seconds. So I will be 0.5 by 5, right? So it's 1 upon 10, or we can say 0.1 ampere is the current that is flowing through this conductor. Okay. Now let's see this problem. A polythene piece rubbed with wool is found to have negative charge this much, right? So Q is 3 into 10 raised to power minus 7 coulomb. Estimate the number of electrons transferred. Now friends, what is the charge on one electron? I just write it over here. Charge on one electron will be equal to 1.6 into 10 raised to power minus 19 coulomb, right? The total charge is this. Charge on one electron is this. So we can calculate the number of electrons. So that's 3 into 10 raised to power minus 7. The total charge, number of electron is supposed to be N, and this is charge on one electron, right? So this is charge on one electron. So N into this charge will be the total charge that is flowing or that is transferred. Okay, so N is 3 into 10 raised to power minus 7 by 1.6 into 10 raised to power minus 19. Now we just can calculate it. So 3 upon 1.6 will be 1.8 into 10 raised to power minus 7 plus 19, that's 10 raised to power 12. So the total number of electrons is 1.8 into 10 raised to power 12. The charge on one electron is this. So this into this is the total charge. Okay. I hope you are clear. Now friends, let's see this question. Calculate the amount of work done to carry 4 coulomb of charge from a point at 100 volt to a point 120 volt. Now what is the definition of potential difference? I just write it over here. Potential difference is equal to work done by charge move. Okay, that is the amount of charge that's moved. Now potential difference is what over here? It's 100 volt to 120 volt. So that's 120 minus 100, I can say. So it's 20. Now we have to calculate the work done. Suppose it is W. What is the amount of charge that is being moved? That's 4 coulomb. So W is equal to 20 into 4, that's 80. Okay. I hope you are clear. I just repeat it once again. Potential difference between 2 points is what? 100 volt to 120 volt, that's 20 volt, right? And the charge is what? 4 coulomb. So potential difference is equal to work done by charge moved. So W, we have to find out, that's the work done. Potential difference is 20 and charge moved is 4 coulomb. So W is 20 into 4, that's 80 joule. Okay. And here I would just make a quick recap of the definition of potential difference. What's that? The potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of electric charge from one point to other, right? 1 volt is equal to 1 joule by 1 coulomb, right? That you have to keep in your mind, right? So the potential difference between 2 points is 1 volt if 1 joule of work is being done in moving 1 coulomb of charge from one point to other. Okay, now let's try this question. What is the resistance of an electric arc lamp when hot if the lamp uses 20 ampere when connected to a 220 volt line? Now we know Ohm's law. What's that? V is equal to IR, right? Now V is 220 volt over here. I is what? 20 ampere, and we have to calculate the resistance. So R will be 220 upon 20, so that's 11 ohm. Okay, I would repeat it once again over here. Potential difference across the lamp is what? That's given to us as 220. The current which is flowing is 20 ampere. Just put the value in this formula. V is equal to IR. Put the value of V, put the value of I, and you'll be getting the value of R. That's 11, and the unit of resistance is ohm, so it's 11 ohm. Okay. In this question, calculate the potential difference required across a conductor of resistance 5 ohm to make a current of 1.5 ampere flow through it, right? What we want, V, what we have, R, that's 5 ohm, and what we have, current, that's 1.5 ampere. Further, the same formula, V is equal to IR. Here I is 1.5, R is 5, so it's 7.5 volt. As simple as that. Okay, so what is the potential difference that is required across this conductor? That is 7.5 volt. Now friends, let's see this problem. A torch bulb has 1 ohm resistance. It draws a current 0.3 ampere when glowing from a source of 3 volt. Calculate the resistance of the bulb when glowing and explain the reason for the difference in resistance. Okay, so we have Ohm's law with us. V is equal to IR. Here V is 3 volt, current is 0.3 ampere, and resistance we have to find out. So it's 3 upon 0.3, that's 10 ohm. Now initially when it's not glowing, the resistance of it is 1 ohm. Now when it is glowing, its resistance is 10 ohm. Why it is happening? The reason for that is like when the current is flowing, what happens? It's becoming, so it's getting hot because of increase in the temperature, right? So since the temperature is increasing, its resistance is increasing. Okay, so I hope you are clear. A current of 0.2 ampere flows through a conductor of resistance 4.5 ohm. Calculate the potential difference at the ends of the conductor. V is equal to IR according to Ohm's law. Now V is what? That we have to calculate. Current is 0.2 ampere. So value of I is 0.2. Resistance is 4.5. So it's 45 into 2, 90 by 100, or we can say 0.9 volt. That is the potential difference at the ends of the conductor. Okay. Now in this case, an electric heater draws a current of 5 ampere when connected to 220 volt. Means calculate the resistance of the filament. Further, the same formula we are going to use. V is equal to IR. Here V is 220 volt. I is the current, that's 5 ampere. We have to calculate the resistance of the filament. Now resistance will be 220 by 5. So that's 44 ohms. Okay. Now let's see this problem. The potential difference between the terminals of an electric heater is 60 volt when it draws a current of 4 ampere from the source. What current will the heater draw if the potential difference is increased to 120 volt? Now friends, we know that resistance of this electric heater will be constant, right? We know that V by I is R, and that's a constant. Okay, so resistance of the conductor will be constant. Now initially V is 60, now V is getting 120. So initially if the current is 4 ampere, now it will be 8 ampere, right? Because V by I is constant. So it's 60, initially it was 60 and I was 4 is to when the voltage was 120, we have to find out I, right? So 60 by 4 into I by 120 will be R, or we can say else what we can do is R can be calculated from here. So it's 60 by 4. Similarly, R will be 120 by I, that's 60 by 4, or we can say 15. So I will be 120 by 15. I'm sorry, R will be 120. I will be 8 ampere. Okay. So V by R is constant, that is R. Initially V is 60 volt. We have taken 60. R current is 4 ampere. So 60 by 4, that's R, that's 15 ohms. Now in the other case, the resistance will remain same. So R is equal to 120, that is voltage by current. So that's 15 ohm only. So I will be 120 by 15, that's 8 ampere. Okay. Now friends, let's see this problem. The resistivity of a wire of length 80 centimeter, length is 80 centimeter, and of a uniform area of cross section is 0.025. So area of cross section is 0.025 centimeter square is found to be 1.50 ohm. So resistance is 1.5 ohm. We have to calculate the resistivity. Resistivity we have to calculate. Now we know the formula. Resistance is equal to rho L by A. Here R is resistance, rho is resistivity, L is the length of the wire and area of cross section. Now what's R? R is 1.5. Rho we have to calculate. Length of the conductor is or wire is 80 centimeter. Area of the cross section is 0.025, right? So from this we can calculate the value of rho. It's 1.5 into 0.025 by 80. Okay. So that is 4.6875 into 10 raised to power 1, 2, 3, 4, that's minus 4. Unit of resistivity over here will be ohm centimeter, because the length of the wire which is given over here is in centimeter, right? So it's 4.6875 into 10 raised to power minus 4 ohm centimeter. Okay. Now in this case, calculate the resistance of 1 kilometer long copper wire of radius 1 mm. Resistivity of copper is this. Now we know the length of the wire is 1 kilometer. Let's convert it into meter or maybe centimeter. Just write in meter. Now radius is 1 mm, right? Now we have to calculate the area of the cross section, that is pi r square, right? Area of the cross section is pi r square, so it's 22 by 7 into r is 1 mm, so it's 1, and if we convert mm to meter, see 10 mm is 1 centimeter, right? And 100 centimeter is 1 meter. So 1000 mm will be 1 meter. Okay, so I have to divide it by 1000. Since it is square, I just have to take the square of this also. So exactly it is 22 by 7 into 10 raised to power minus 6 meter square. That is the area of the cross section. Now we know the formula. R is equal to rho L by A. Now what is the value of resistivity of the copper that is given to us as It's in meter, so take it as it is, 1.72 into 10 raised to power minus 8. Friends, always be careful about the units, right? Here the resistivity is given in ohm meter, and we have taken the length and area in meter, so it's correct. Else if it is given in meter and if you are taking the length and cross section in centimeter, then you will getting wrong answer. So it's 1.72 into 10 raised to power minus 8. Length of the wire is 1000 and area of the cross section is 22 by 7 into 10 raised to power minus 6. Okay, so it's 7 into 1.72 into 10 raised to power minus 8 plus 3 and plus 6 divided by 22. Okay, so it's 7 into 1.72 by 22 into 10 raised to power 6 plus 3 9 minus 8, so it's just 10. Okay, so it's around 5.47 ohms. Okay, I hope you are clear. So in this case, we had to calculate the resistance of this wire, that's 5.47 ohm. Now friends, we have done good number of problems at this session. We'll be continuing with problems in our next session as well. So let's meet in the next session once again. Bye bye.